Happy Monday, everybody. Today we're going to continue thinking about the graphs that you can make for proportional relationships. So, looking at this was our practice check. I asked you which of these are not proportional. Important to read, which are not proportional. And what I heard from a lot of people during the homework check, as we were looking through people's revisions, were that it needs to do two things mostly. A proportional graph needs to start at the origin, not the origin, like some people said, the origin, which is 0, 0, and it needs to form a straight line. So if we know those two things, then we should be able to rule some stuff out. So this one, if this is the origin, it is not starting at the origin. Oh, so that's good, because it's not. Because like I said, reading is important. This one is curving rather than going in a straight line, so this would be good because it is not proportional. This one starts at the origin and forms a straight line, so we don't want that. This one starts at the origin, is a straight line. We don't want that because those both would be proportional. And then to confirm, because I don't want us to just trust, like, oh, if it looks like that, we're good. Let's look at some examples. So I'm going to pick this point here, which would be 0. So my x would be 0, and my y is 5. And how about this one? My x, 5, 1, 2, 3. Ooh, here, let's do 5. There. X is 5. Y is between 20 and 30. It's 25. Okay. Well, to get from 5 to 25, I would have to do times 5. 0 times 5 is absolutely not 5. 0 times 5 is 0, so this one is not proportional, which is what I wanted. And then for C, so that's B. And then for C, we have our x and our y. Let's say 2, so if we're over, x is 2. Y would be in between 0 and 20, so y would be 10. And then that's another one that would work nicely for us. How about this one? 2, this would be 3 because it's between 2 and 4. 3 would be 20. Well, to get from 2 to 10, you have to multiply by 5. But if you do 3 times 5, you will not get 20. 3 times 5 would be 15. So this is also not proportional, and that backs up what we noticed visually. The combination of data tables and equations is often very helpful here. Cool. So here I asked you to invent some situations. We had people who talked about super depressing chocolate chip cookies, 16 cookies that only had 12 chocolate chips total, and things like that. But really at the end of the day, it came down to having quantities that you could scale up and down. If we have 16 of something and 12 of something, then when we have 8 of that same original, then we're going to only have 6 of the related quantity. All the way back to if you have nothing of one, you will have nothing of the other. So let's look at what that looks like for this scenario. We've got Denia. She decided to go to Fright Fest, freak herself out a little bit. Let's see if we can get that's better. And she's getting tickets at the ticket booth. So my first question is she going toward the ticket booth or away from the ticket booth? How could we figure that out? Well, looking at the point 40, 50. 40, that would bring us down. That's our elapsed time. So we would say after 40 seconds, what has Denia done? Well, let's look at 50. We go over, 50 is going to be the distance. So after 40 seconds, Denia is 50 meters from the booth. Well, we know that it's a proportional relationship, so it would start at 0, 0. We also have information 20 to 25, which would be taking that and scaling it down. In half the time, you'll go half the distance. 30 would get you to there. 40 would get you to 50. So we've got this straight line forming, looking proportional. And looking at that, if she's here, so 0, 0 means after no time, Denia is 0 meters from the booth. that means she's at the booth. So at the beginning of this, after no time, she's at the booth, and after 40 seconds, she's 15 meters away. So that means she's traveling away. She's leaving. She got her tickets, and now she's heading away from that booth. But the question is, how fast is she going? So for that, we need to think about the unit rate. After 1 second, how many meters is she going to go? Well, we can find that on our graph. If we have 10 here, 5, come kind of really close to 1, right there. That would be after 1 second, and then how far away is she? Well, we know we're on the line. We know that it's less than 5 meters because it's kind of under here. We don't know exactly how much it is. It looks like maybe it's around 1 meter away, but we can't be sure from eyeballing it. So let's be sure by doing some calculations. To get from 40 seconds to 1 second, well, we can scale that down, divide by 40. Then we need to do the same to the distance because it's proportional, which means that we're going to have 5/4, or that's 1.25 meters. Is that close to 1 meter? Yeah, that looks pretty good. This could be 1.25, and I would believe that that's how far up the graph we are. So then that 1.25 meters are being traveled every 1 second. That's how fast she's going. It's pretty speedy. I'd call her a speed walker. And things to note. Once you have your line, really once you have 1 point and you can connect it to the origin, because we know that a proportional graph goes through the origin, you have all these other data points you can look at. One of the really powerful data points is that unit rate, because that is also your constant of proportionality. So we could just say this, everything is times 1.25, which then also gives you an equation. T times 1.25 is going to give you the d distance. So once you can get down to 1 of something, you have a lot of power in doing your calculations. I want to just remind you what we did with the practice, the Connect 4 practice. Since some groups get to talk about it more than others did. So in this, we have a really bizarre scenario. 4 seagulls ate 10 pounds of garbage. This does happen, though. We're in the Great Lakes, so there are a lot of gulls eating a lot of garbage. And we're assuming that this is a proportional relationship. So if more seagulls are eating, they're going to eat more garbage. If fewer seagulls are eating, they're going to eat less garbage. So we want to plot a point that shows that. So 4 seagulls, well, here's my number of seagulls. So I need to go over to 4. 10 pounds up here, so I need to go all the way up to 10 pounds and plot that point. That would be 4, 10. Now I use a straight edge. I had people who were like, can I have a folder or a ruler? No, you can have anything that's a straight edge. So here, this paper forms a straight edge. How handy. So I'm going to plot on there. And now this, I want to plot the point 1 something, because that's going to give me my unit rate on here. Well, I'm going over to 1, so 1 seagull. If I go up, they're going to eat, that's my point, they're going to eat between 2 and 3 pounds of garbage. But I want to be more specific than that. So let's think about if we have our x and our y. 4 to 10. Well, I want to get down to 1 seagull, so dividing by 4. 10 divided by 4 is going to be 2.5. So every seagull, oh, good, that's between 2 and 3, so that fits what we were saying. Every seagull, every gull gets 2.5 pounds of garbage because those gulls are hungry and they want to eat your trash. I did once have a gull actually take food right out of my hand. It dove down, took my shrimp away from me, and it was a really sad and scary day. So gulls can be pretty vicious. Okay, as you're looking at your homework tonight, think about what's going on with these graphs, how they look, and then really getting down to that unit rate. What can you do there?